Welcome back to the Explainer. I always used to think of fire as this totally chaotic, unpredictable force of nature. But while diving into our source material for today, I realized that fire safety is actually an incredibly precise, almost elegant science. Today we're going to deconstruct exactly how fires operate at a fundamental level. But more importantly, we're unpacking the specific components, the usage, and some real-world examples of the tools engineered to stop them. We're moving past the panic and the alarms to look at the pure mechanics of combustion.
Here is our roadmap for today. 1. Anatomy of a fire. 2. Know your fire classes. 3. Extinguisher components. And 4. Usage and examples. Let's get right into it.
Section 1. Anatomy of a fire. Let's look at the combustion process. So at its absolute chemical core, fire operates on a really strict, unforgiving rule of 3. We call this the fire triangle. To start and actually sustain combustion, you need exactly 3 components. First up, oxygen, specifically O2, which, is just hanging out in the air around us. Second is your fuel. This could literally be anything from cooking oil to the wood studs inside your walls. And third, you need heat, like a spark or a match. It's a literal recipe. If you perfectly combine these 3 elements, boom, you get the chemical reaction we call fire. But here is the genuinely fascinating part. You absolutely need all 3. Take away just one, the fire simply cannot exist.
And honestly, once you fully grasp that chemical triangle, the solution to putting out a fire becomes incredibly elegant. It's not just about brute force. It actually comes down to starvation or suffocation. To stop combustion, fire extinguishers are engineered to simply remove one or more of those 3 components we just broke down. You either take away the heat, block the oxygen, or eliminate the fuel. Break the triangle, and you kill the fire. It really is that chemically straightforward.
Moving on to Section 2. Know your fire classes. This is all about the types of fuel.
Building on that foundation, we actually have 4 distinct classes of fire. And let me tell you, treating them all the same is a literal recipe for disaster. This is where things get incredibly specific. Class A involves your ordinary combustibles, stuff like trash, wood, paper, and cloth. Then there's Class B, which covers liquids and greases like gasoline or cooking oil. Class C introduces energized electrical equipment, so here we're dealing with live currents inside computers or server racks. But take a close look at Class D. These are highly combustible metals like magnesium, sodium, or titanium. To give you a prime example of why knowing this matters, if you throw standard water on a Class D magnesium fire, you can actually cause a violent explosive reaction. You're essentially adding fuel to the fire. So instantly identifying your fire class and matching it to the exact right tool is absolutely the most critical first step in any emergency.
Section 3. Extinguisher components. Time to physically deconstruct the tool itself.
When you walk past one of these in the hallway, it's so easy to just see a red can. But it's actually a highly engineered, pressurized vessel built for an exact, singular purpose. Check out the sturdy body. That acts as the main storage tank, holding everything inside under intense pressure. Up top, you have the carrying handle for rapid balanced transport. And then there's the discharge hose, which routes the extinguishing agent straight down to the nozzle, ending in a specific discharge orifice. Every single one of these components is designed for maximum reliability, because in an emergency, failure is simply not an option.
Zooming in on the mechanics here, understanding these specific parts is literally life-saving knowledge. At the very top, you've got your trigger, the discharge lever. But you can't just squeeze it. It is locked down by a pin and a breakable seal. That's to prevent you or anyone else from accidentally setting the whole thing off. Then right below that is the pressure gauge. This gives you a really quick visual check to ensure the unit is actually fully charged and ready to fire. But here's a truly fascinating detail from our sources. You actually won't find this gauge on CO2 models. Because of the way carbon dioxide is compressed, a standard gauge just wouldn't give an accurate reading. Finally, that flexible discharge hose gives you the precise directional control you absolutely need when every single second counts.
Which brings us to Section 4. Usage and examples. Let's look at real-world application.
According to the source material, real-world usage relies heavily on 2 major operational acronyms. The first is RACE. This dictates your immediate response to a fire, rescue anyone in immediate danger, sound the alarm, contain the fire by closing doors, and only then attempt to extinguish it. Now, once you actually grab that carrying handle to fight the flames, you switch over to pass. You pull the pin, breaking that seal we talked about, you aim the nozzle low, pointing directly at the base of the fire, you squeeze the lever evenly, and you sweep from side to side until the flames are completely out. You absolutely have to internalize these steps before you ever face a real fire. So, we've got the anatomy, the fire classes, and the core operating procedures down. But what does this actually look like in practice? Let's bridge the gap between all this theory and reality and look at a concrete example of one of these units in action.
Let's take the pressurized water extinguisher as our key example today. Remember our fire classes from earlier? This specific unit is strictly for Class A fires. That means trash, wood, and paper only. Never, ever use this on a grease or electrical fire. It holds 2.5 gallons of water and gives you up to a full minute of continuous discharge. And let me tell you, a minute is an absolute eternity when you're fighting flames. But what genuinely surprised me in the sources was its range, 30 to 40 feet. That means you can effectively fight a fire from the entire length of a school bus away. Plus, because of that highly engineered discharge lever we looked at, you aren't forced to just blast it all at once. You can actively start and stop the flow so you can systematically assess the situation.
And this perfectly brings us full circle. How does this pressurized water unit actually do its job? Well, it uses a cooling mechanism. By soaking those Class A materials, it rapidly drops the temperature of the burning fuel completely below its ignition point. It's a targeted, localized attack directly on the heat side of that fire triangle we deconstructed at the very beginning of the explainer. You take away the heat, you break the triangle, and the fire dies. So, we've covered the fundamental chemistry, the specific fuel classifications, the intricate anatomy, and the exact specifications of real-world usage. But you know, all of this information is totally useless if it just stays theory. So I want to leave you with this. Take a look around the room you're sitting in right now. Do you know exactly where your nearest fire extinguisher is located? And more importantly, if you go read its label, what specific class of fire is it actually built to fight? Take the knowledge you gained today and go find out. Thanks for exploring this explainer with me, and stay safe out there.